So today we're going to be talking a little bit about square roots. So first of all, you're probably interested in how to solve a square root. So basically, to solve a square root problem, you need to find a number that when multiplied by itself, so for example, if you have any number b multiplied by itself, so any number multiplied by the same number, that will give you the radicand. And radicand is a bit of an interesting new term that you might not have come across, but we're going to explain every element of a square root problem that you could come across. So first, let's start with the radical symbol. The radical symbol is this little squiggly bit, or just this defining characteristic of a square root problem. And basically this tells us that we're looking at a square root problem, right? So it could also tell us that we're looking at a cubed root or a fourth root, etc., etc. And this is determined by a little number in front of the radical symbol, this line. So for example, here it's 3, here it's 4, and this number is called the index. But we'll learn about that later on in math, so for right now, don't worry about that too much. So yeah, for now, when we see this symbol, it just means we're looking at a square root problem. Here we have the radicand. This letter I've assigned to the radicand is A, and the radicand is basically a fancy term for the root times the root. The root is this letter B that's the letter I've assigned to the root. And so that's usually what we're going to be solving for in square root problems. Not always, but a lot of the time. So to find this relationship, we can actually use what I wrote here. The radicand is a fancy term for the root times the root. So if we write that in a mathematical way, we get A, or the radicand, is equal to the root, which is B, times itself, or B times B. If we write this in a more compact way, we get A is equal to B squared, because we know that a number times itself is equal to the number squared, or a number times the same number again is equal to b cubed, and so on and so on. So now that we have this more simplified relationship, we can apply the square root to both sides, and this is really important. The square root cancels out an exponent of 2 and the square root symbol. This means that we're left with our final relationship of b is equal to the square root of a. That's the same relationship that we have here. So we can derive this relationship from the relationship between the radicand and the root. This is the same relationship as this, only you may notice that we're solving for different things. So think here, what are we solving for in this equation? I'll give you a few seconds to think about it. So if you've got that, we're solving here for the root, because the root is equal to b in this case. I can spell that better. But over here, what are we solving for? What is a equal to? A is equal to the radicand. I don't know if I have space to write that necessarily. We'll try. So they're the same relationship, but in algebra you can solve for different variables. So depending on what you're asked in a question, if you're asked for the radicand or you're asked for the root, you can use the relationship and shift it to solve for either b or a, depending on what the situation calls for. So a lot of people find it easy to think of the square root as an actual square. So if you've encountered square root problems, we know that the area is equal to the length squared in a square. So you could also write that as A is equal to L times L. And so that can actually help us to come up with the relationship between a square root as well. Because like we said earlier, the radicand is equal to the root times the root. So if we think of the area as the radicand, we can say that A is equal to the root, which we have as B, times B. I'm going to write these variables on the side to make that a little bit more simple for you guys. If we think of the radicand as A, well, it is A, sorry. I should have used a different variable there, but if we look back here, I said the radicand is equal to a, so we put a there, and the root equal to b. So if we think of that as a square, we can come up with this initial relationship. From there, this basically serves as a trick of memory, and then once we get to this relationship, we can simplify. Since I already did this above, I'm going to do this just really quickly so you guys can see. The important part, again, is the cancellation of that power of 2 with the square root sign, or the radical sign, and then we get our final relationship that solves, again, for different variables depending on the situation. So here, for example, we have a root equal to 3. So the root equal to 3, let's write down our variables. The root I've written as is the variable b. So b is equal to 3, but what is the radicand? The radicand is equal to a. So we're going to try and find a relationship that we've created here that holds true for all square root problems of this type, and apply that. So what is a equal to? Well, in what relationship have we solved for a? A here is equal to b times b, or the radicand, which is a, is equal to the root times the root. So we can just write this relationship down. A is equal to b times b. Therefore, a is equal to 3 times 3, which is also equal to 3 squared, which is equal to 9. Therefore, a radicand is equal to 9. The next problem here is solving for a different thing. We're solving for the root instead, but it's the same set of steps. So we're going to write down our variables. The letter I've assigned to the radicand is a, so a is equal to 49. What is the root? Well, what's b? The root, the variable that I've assigned to the root, is b. So let's find a relationship that solves for b. If we look to the left here, we can see that the relationship that solves for b is the square root of a. b is equal to the square root of a. So that means b is equal to the square root of 49. Now that brings us to the question, what does that square root sign even mean at all? Basically, what it requires us to think of is a number that when multiplied by itself will give the number that is equal to a. In this case, it's 49. So what's a number multiplied by itself that will give us the number 49? You have to do some multiplication for this, but basically it is 7, because 7, right, this small times 7 is 49. Moving on to some more problems. So what is the number whose square root is 3 over 8? So the number whose square root is 3 over 8. The first thing we're going to do is identify the variables. So the square root is our root. So we've identified the root as b. So b is equal to 3 over 8. We're looking for a, the radicand. Which number would have a square root of 3 over 8? So we're going to go back here and try and find a relationship. Here, we found it. A is equal to b times b. So, to find this, we're going to have to multiply 3 over 8 times 3 over 8. So, 3 times 3 is 9, 8 times 8 is 64. Multiply the numerator by numerator and denominator by denominator, and that means we've got our a value. Therefore, a is equal to 9 over 64. Now on this side, the number whose square root is 2.3. The difference here is that instead of having a fraction, we have a number. So, same thing, identify our variables. We know that the square root is equal to b, which is equal to 2.3. And we're looking for a. Which number would have a square root of 2.3? So again, we use the same relationship. A is equal to b times b. And we're going to apply that. So a is equal to 2.3 times 2.3. And that is, if I am not mistaken, 5.29. Yeah, 5.29. So our final question of the day is the fraction 4 over 9 a perfect square? So I have to the right a little thing you can think of in your head to ask yourself if something is a perfect square. If you can find a number times the same number, that is equal to the number given, in this case 4 over 9, it is a perfect square. So if this is true, it's a perfect square. If you can't find a number times itself that will equal a, or the radicand, then it's not a perfect square. So if this is not true, not a perfect square. If it is true, it is a perfect square. So let's think to ourselves here. If you have a fraction, you can figure this out pretty easily. So 4 over 9. I like to think of this as separating the numerator and the denominator. If we just look at the numerator, let's think to ourselves, what's a number times a number that will give us 4? And then in the denominator, what's a number times a number that will give us 9? So for 4, pretty easy, we can think 2 times 2 is equal to 4. Therefore, we have a b for the numerator, or a number times a number that will give us the numerator. In the denominator, we can think of that number as 3. 3 times 3 is equal to 9. So therefore, both the denominator and the numerator have a b value, or a number times a number that equals the number given. So whether that be 4 or 9. When we put this together, we can realize that 2 over 3 times 2 over 3, and I got these numbers from just making this a new fraction. So I brought these numbers and I created a new fraction. And then that will give us 4 over 9. This means that this is the b value for the total fraction, 4 over 9. These are the individual b values for the numerator and the denominator, so whether that be 2 or 3, but when you put it together into a new fraction, we are given the b values, which means that if we return to this definition, we found a number times a number that equals the number we've been given, 4 over 9. So therefore, yes, it is a perfect square. We're just going to write the answer more plainly. Therefore, it is a perfect square. All right, so that was our lesson on an introduction to square root problems. I hope this was helpful, and I'll see you next time.